Okay, let's keep going. So before the break, we talk about how to do the scientific notation. We use the big number. And I told you, okay, find the decimal point, and then you take a step. Every time you take a step is 10. So 10, another 10, and another 10. You have 3 tens. You move decimal point to here. So you find 1500 is 1.5. That's your first number. Multiplies 10 to the power of 3 because you step to the left 3 times. Now let's keep going. So now let's look at the small number. Small number. 0.00056 is a small number. How do you turn this into scientific notation? And again, I told you no matter how big, how small this number is, I can use scientific notation. So it can fit in big number, it can fit in small number. So first we find the decimal points that's here, right? Okay, now we step to the right. Every time you step to the right, it's -1. Okay, -1, -2, -3, so 0.56, not enough, right? Okay, -4, 5.6. You have to move the decimal point to here. And you step to the right 4 times. Okay, so the first number is 5.6. And you step to the right 4 times. Every time you step to the right is -1, so totally -4. That's how you do the scientific notation. So no matter how big, how small the number is, you can fit in this kind of formula. Always a number multiplied 10 to the power of b number. Okay, so again, this one, 0.000001. Okay, a lot of zero. Okay, doesn't matter. We find the decimal points. That's here, right? Okay, take a right step, -1, -2, -3, -4, -5. Are we done? No, because this number is 0.1. The number need to be bigger than 1. So -6, we move to here. We move to here. So you step to the right 6 times. So the A number is 1. And B number is -6. So that's how you do the scientific notation. You find no matter the number is big or the number is small, you just use the scientific notation. You always fill in the number A multiplied 10 to the power of B number. And the rule of A number is it need to be smaller than 10, need to be bigger than 1. And the B will always be the integer. Okay, so this scientific notation. There's the power of scientific notation, no matter how big, how small. Okay, and then 2 more practice. Don't use your pen, use your head. So I tell my student, use your head to do the calculation. You can do it. You can do it. Okay, so the decimal point is not this, right? Decimal point is here. Okay, and now we step to the left, means this number is a big number. Okay, 1, 2, 3, 4, 5, right? You need to move the decimal point to here, 5. Okay, so could you tell me the first number A is 1.23, and multiply 10 to the power, you step 5 times. So 1.23 multiply 10 to the power of 5. And this, if you are familiar with this, you can go even faster. Decimal point is here. Okay, you step to the right because it's a small number. Step to the right. So -1, -2, -3. So 8.35. That's the A number. Multiply 10 to the power of, you step how many times? 1, 2, 3. So to the power of -3. Remember, every time you step to the right, it's negative. You step to the left, it's positive. So 8.35 multiply 10 to the power of -3. That's the scientific notation. So no matter how big, how small, you can fill this number into this formula. That's why scientists like to use it. And the first number is called the coefficient. The second number is called the exponent. Okay. One more. Okay, you find a comma, right? So every comma means 3. So this kind you can jump. You can jump. Decimal point start from here. Okay, 3, 6. So it's 36 multiplied 10 to the power of 6, right? But it could not be 36. So it need to be 3.6, step 1 more. So it would be 3.6 multiply 10 to the power of 7. So you can jump 3, 6, 7. Good. So the answer of this one, 3.6 to the power of 7. And I will ask you similar questions in the test to make sure you can do the scientific notation. Okay, what's this one? Decimal point is here, right? Okay, so it's a small number. -1, -2, -3, -4, -5. So first number is 5.23. To the power of, if you forget, count again, -1, -2, -3, -4, -5. To the power of -5. It's supposed to be small. Okay, so that's scientific notation. And that's the most difficult for today. Okay, so you know, okay, the scientific notations, and the rest of them will be much easier. Okay, the unit, you also need to know the unit. Okay, micro, you learn this is 10 to the power of -6. So suddenly all this prefix makes sense. Means it's very small. Micrometer, micrometer. Together, prefix and metric unit combined is called a micrometer. Abbreviation, micro, we use the Greek number. Greek number, this means micro. So micrometer, that's what it means. You see this a lot in biology because bacteria is in this scale, in this length scale, micrometer. You could not see it with naked eye. Okay, next one, kilogram. Kilogram. Kilograms used to measure your body weight. So kilo means 1,000. So it actually means 1,000 grams. And kg, that's the abbreviation. Okay, milliliter together, prefix metric unit, just put these two together, milliliter. Milli means use M, liter, L, milliliter. Next one, nanometer. Milli is 10 to the power of -3. So it's actually 1 divided by 1,000. If you forget the previous few slides, we talk about it. Okay, nanometer. Nano is 10 to the power of -9. So it's 1 divided by 1,000 and then divide by 1,000, divide by 1,000 again. So it's a very, very small distance. We use nanometer to represent the wavelengths. So nanometer abbreviation is this, nanometer. Next one, microgram. Micro, we talk about this. Micro is 10 to the power of -6. So it's a very small number. And we use the Greek number. This means micrometer. So micros, gram is a very, very small weight. It's 10 to the power of -6. Abbreviation, this is micro m. Millimeter, 1 divided by 1,000 meter. So it's a very small scale. So m is the millimeter. So these are the abbreviation. Okay, and when we are measuring the length in metric system, so there's the typical ruler. You find this is inch. And now we look into this. So this is 1 centimeter, like 21 to 22. From here to here, this 1 centimeter. And then you find it divided by 10. And when you count to 5, then make this number a little bit bigger. It's a little bit longer. So it's easier to see there's 5, there's 10. So each one of these tiny one, this is 1 millimeter. This is 1 millimeter. So 1 centimeter divided by 10 is 1 millimeter. So 1 centimeter equals to 10 millimeter. Okay, and the last one is when you look at the volume. Also, when we go to AP1, you will start to measure the volumes. Because water have a big surface tension, they will have the concave surface when you pour water into the graduate cylinder. So what's the correct volume when you move high or move low, you will misread the number. So the correct way is, well, you put your eyes in the same horizontal line. So look at the concave, right? Concave, yes. Convex, concave, I always mix these two. Concave ones, this area. So that's the correct number. So for example, if I give you this, you know this will be 6.6, right? Because this line, this line. 6.1, 2, 3, 4, 5. Every time you go to 5, they will make the long a little bit longer. The line a little bit longer. It's easier to see. And 6. So this is 6.6 milliliter, actually. Yeah, it's not 7 yet. So that's how you read the volume. Okay, that's it.